Wow. All right. Welcome, lunchtime crowd. Is everybody enjoying the show so far? I'll take that as a resounding yes. I can tell. I can tell that you are. Well, my name is Blaine. There we go. My name is Blaine Mathieu. And I run a company called Protexo based in Malmo, Sweden, and Austin, Texas. And we're here today to talk about LoRaWAN and edge computing, how we can partner together to save IoT and AI. And you might be wondering, do IoT and AI really need saving? Well, let's see. Maybe. Here's some Google Trends data. Now, these aren't to scale, but they show the relative scale of these two search terms for IoT and AI in the form of machine learning. And it's interesting, around 2014, these search terms really started to take off, get a lot of traction, and then something happened in 2019. I've got a theory about what happened. You might have one too. I think it might have something to do with a crisis of complexity this industry is in, and the fact that a lot of industrial companies, infrastructure companies, and others started a lot of pilots and POCs, and they hit a wall. And here's the wall I think many of these companies are hitting, and have hit and are still hitting today. I think many of you are you're either trying to solve this or trying to help companies solve this, right? Start with just collecting and analyzing data, right? Taking data from being dark to being actually value generating. Get some dashboards up, show what it means. Then you want to move towards generating alerts and notifications, the basics of taking action on data. Then you want to get to predictions and predicting things, more intelligent applications, not just analytics, but applications that can do preventative maintenance and a lot of other interesting use cases. And then finally, enable real-time, autonomous, highly efficient system control. That's really the nirvana, right? The lights-out operation that maintains itself, and you can just let it run. That's all good, and most companies are somewhere in that digital transformation journey. But meanwhile, they're putting up with a crisis of complexity. More and more data coming from more and more devices, streaming it at increasing rates, more applications they have to host. Now they're starting to run machine learning models on this data. How do you deal with this? Well, one way you don't deal with it successfully is to try to put all of this data into a central cloud. I'm a former Gartner analyst myself, don't hold that against me. And Gartner now counts over 300 IoT platforms that they know of, that they're counting today. And the vast majority of those IoT platforms are still fundamentally putting data into a central cloud. Works fine when you're doing a pilot or a POC at low volume. When you're actually trying to run a real system, high volumes of streaming data, you cannot make your way across that graph at the bottom. So my theory is you need edge computing combined with tools like LoRaWAN to really unlock that value and get AI and IoT out of its slump. And in fact, it's really interesting, and I don't think it's a coincidence, that edge computing on about a 3 or 4 year lag to those terms makes a lot of sense, right? They see they're hitting a wall. How do they solve that wall? The wall caused by everything trying to go into the cloud. They try to solve it, and they're not solving it now with edge computing, and we'll tie LoRaWAN in a second. So let's talk about going from device to the edge to the cloud. So think about it this way. You've got all these devices in hospitals, in smart buildings, on oil rigs, in power grids that are generating all of this data. You've got local edge computers that are processing most of that data locally. In some cases, and we'll talk about this more on the next one, you've got these edge computers actually working together to form what we call microclouds down at the far edge. So you're not only processing data, but you're bringing the power of cloud computing down to the edge. And then, of course, it's not just edge and cloud. We know there are many tiers of edge on the way to central clouds. This might be your telco 5G MEC edge, or maybe it's a regional microcloud that you've set up across to monitor your entire electrical grid. And then finally, central clouds, of course, have their place. We know that for ERP, CRM, HRM systems, repair ticket management systems, for training machine learning models, central clouds are fantastic. But for streaming terabytes of raw data off your machines and systems, not fantastic. Let's go one click deeper into what we mean by edge computing and local microclouds in case you haven't been exposed to the concept, especially microclouds. So edge computing, I think you're all quite familiar. It's the notion of processing data locally, instead of pushing the data somewhere else, keeps it more private, more secure, helps with compliance. Many of the countries in Europe disallow by law hospitals from pushing their IoT data up to a cloud. The Norwegian power grid, again, by law, they're not allowed to put that IoT data up to a central cloud through the public internet, right, for security reasons and to keep these systems from being hacked. Of course, a lot of edge computing is being driven these days because the cost of storing and processing data in central clouds is getting ridiculous. Another example of when you're doing a pilot or a POC, these systems are almost free. AWS, Azure, they're great systems and nearly free at low volume. At high volume, they're not nearly free anymore, and I can't tell you how many times I've heard clients and partners say that's a key reason why they realize they need to process more of this data at the edge. But don't just stop with edge computing. Think about this notion of microclouds, decentralized clusters of edge nodes working together that can actually bring the power of cloud computing down to the far edge. So instead of bringing the data all up to a cloud, bring the cloud down to the data, right? You can get that elastic nature of cloud computing. You can host multiple applications and analytics models to run in real time on that data without having to try to push it all up to the cloud. And because your system is being run locally, your applications and analytics, they continue to run even if they're disconnected from your central clouds. For mission-critical systems, this is absolutely critical. So edge computing, and then one step further, edge microclouds. Now let's think what we're going to do with this. We're going to want to run increasingly intelligent applications on the edge. My former Gartner colleagues say, I think 65%, of edge computing use cases will involve AI, machine learning, deep learning by 2027. Pretty incredible. And I know most of you are in some transition toward those intelligent applications right now. So for object detection, pose detection of people on a manufacturing line, safety, security. I've got one interesting system that's using cameras to read steam gauges and translate that into digital data, which then can be read by a machine, right? So most companies are starting small, simple, basic algorithms, heuristics, models that they're running in real time. But meanwhile, they're recording data, not trying to push, again, all of this training data up to a cloud, but recording it locally, picking out the important bits and sending that to central clouds for model training, doing that training, and then gradually streaming onto their industrial edge intelligent applications fed by machine learning models that can then learn and improve and continuously optimize over time. That's what's possible with edge computing and microclouds helping IoT and AI. So let's tie LoRaWAN into this now. Everybody, I'm sure at this conference, knows the strengths and weaknesses of LoRaWAN quite well. Really good for non-real-time analytics, reporting the status of systems. Not so good for real-time system control because of latency and some of the other issues that are related. Not issues, it's just the capabilities of LoRaWAN, right? Interesting that 5G is almost the exact opposite when you think about what 5G is capable of. So maybe we can put together interesting systems that make use of edge computing, LoRaWAN, IoT, AI, and maybe we'll throw in 5G and a few other things as well. Well, how would we do that? And by doing that, get to where we need to be sooner rather than later on this chart. So here's a scenario. So suppose you've got a bunch of devices, like I'm amazed at the volume and scope and the range of devices that are out in the show right now connected to a LoRaWAN gateway, and maybe we've got a couple of gateways running, and those gateways are aggregating that data and they're sending it to a local microcloud, which is running in your physical plant, in your manufacturing operation, maybe in your power grid at a regional power transformer station. And the connection to that microcloud is thick. Maybe it's 5G, Wi-Fi, could be fiber, you name it. In addition to that, you've got a bunch of other sensors that are connected by other means into the microcloud. These are ones that are putting off massive amounts of streaming data, video cameras, PLCs, connected to transformers, you name it. And in fact, we look at things like robots, transformer stations, EV recharging stations. They put off tons of data, right, that are necessary to track the telemetry of these systems. And then, of course, you've got central clouds. So there is almost always a place for putting some kind of event data into a central cloud, into an ERP system or whatever the case is, so that kind of connection is made as well. But it's the local microcloud that's really tying all this together, tying this complete end-to-end ecosystem, including LoRaWAN and fatter connections, devices together. And these information flows go in two ways. It's not just about putting all data into a microcloud on the edge and then up to a central cloud. It's about controlling and analyzing this data and taking action in real time. So what do we get out of this? We get visibility across the entire event horizon, right? And what I mean by that is all these devices, machine systems, you get a central view of everything that's going on in an integrated manner, which is necessary to run intelligent real-time applications. You get highly reliable real-time machine control, which is part of the end game that I think we're all shooting for here. And all of this continues to work even if you are disconnected from central clouds. So is this happening today? Is LoRaWAN and edge computing being combined into these systems? Well, back to our friend Google. These items are to scale. This is the identical scale between these two. It's not only 100% correlation between LoRaWAN and edge computing since 2014, but actually literally at the same scale. These technologies are tracking each other, and they absolutely are being used together to solve some of the key challenges of AI and IoT. Let me end by answering a question some of you might have in your mind. So what does Protexo have to do with any of this? Let me give it to you really briefly. So the Protexo platform, in particular, the element we call the Pratexo Studio, enables an architect or a system integrator to design these edge software ecosystems and microclouds that I was talking about, to create a digital twin of them, to be able to test them before you ever connect any physical piece of hardware, a device, a sensor, or an edge computer to anything. You run the digital twin and test it. Then, of course, you do the deployment, the physical deployment to the real world once you've done the testing, and then manage, monitor, and maintain this system going forward, because once you launch something, that's just the beginning, right? It's not the end. You're going to continually want to add new applications, change your analytics models, stream a new machine learning model down, so you have to be able to manage and maintain it on an ongoing basis. And I love this quote from Audun Grønning, the CEO of HKN, a Norwegian power grid operator. Audun's actually in the crowd here. Audun, there he is. You can grab him later in the audience if you want to chat with him. He and his companies are actually doing this today, what I was just talking about, including LoRaWAN, some interesting new municipal water monitoring use cases. So if you want to talk to an actual practitioner who's doing this in the real world today, find Audun at some point or reach out to him afterward. Give you a quick look at what the Protexo Design Studio looks like. So what's happening here is the architect is grabbing some device types onto the palette, integrating them with the software that's running on each edge node. So every component here is running across every processing node that's running in this ecosystem. He's putting in a wave analyzer to actually, this is an analytics model, to analyze the data which is coming in off this microphone, to listen for the sound of partial discharge in this energy grid. That's what this application is. And on the left here, we've got the applications and components that are being stored and distributed across all the edge nodes across this microcloud that I was talking about. So this is true distributed computing, creating a resilient, scalable set of software that's going to continue to run even if any individual node goes out or stops operating. This is how you very rapidly design and ultimately process and deploy a microcloud and edge architecture like this, either to a simulation environment or to the real world. So think about it this way again. The Protexo Studio does that design, simulation, deployment of the analytics and applications that need to run in real time to actually help you along that journey that I was talking about. And you're doing that because you've got a lot of very challenging operational goals and targets that you have to hit, and I guarantee you, you cannot hit them by putting all of this data into a central cloud. But using LoRaWAN, edge computing, you can unlock the full value of AI and IoT for your business. So I'm with Protexo. We were the Edge Computing Startup of the Year last year, and please do feel free to reach out to me at any point in time if you'd like to learn more. Thank you.